All right, let's do it. Okay, let's not get sued here. This is Brand Academy. All right, so here's just one practice problem, okay? This is a practice problem before we actually start the notes, but please write this down, okay? So this is part of it. So if you can like put this somewhere on the side of your notebook, that'd be great. Okay, we're gonna solve this algebraic equation, but doing it as a proof, okay? So when we're doing this here, we're gonna kind of practice a two-column proof. So on the left side, you can put your statements. And on the right side, you're gonna put your reasons, okay? Statements and reasons, okay? Okay, your goal right now is to pretend you're a tutor. You're a tutor and you're tutoring like a second grader, okay? A second grader on how to solve this problem. Okay, so you're gonna be very detailed. You're gonna explain every step. So in math, right, if you're a good math teacher and a student asks you for help, what's the first thing you would, the first thing you would tell them to do? What do you guys think? Student asks for help. How do you do this problem? What's the first thing you would tell them? We just type in the chat. Let's see who has that teacher blood in them. Distribute. PEMDAS. The most basic thing. You guys remember what teachers always tell you? Solve. All right, just solve for it. Okay, the first thing teachers probably say is write out the problem. Yeah? No? Sometimes kids won't even do that, right? They will write out the problem. Okay, and this step here, good job, Isaac. This step here is what we call given, right? The reason for that, the reason for statement number 1 is because that's given to you, right? You write it out. Okay, step 2 now, after you write down the original problem, is what you guys are saying, you're gonna distribute, right? So once you distribute, you're gonna have 6x plus 2x minus 1. Actually, I'm gonna make it a different color just to 2x minus 2 equals 30. Okay, boom. Now you distribute. So basically, to get step 1 to step 2, what do? You distribute, right? That's the reason for that. Distribute. Okay, after you do that, what people will probably say here is you need to add like terms, right? So you probably want to add these up here. Let's call it green. So this here will become 8x minus 2 equals 30. The reason for that, people can say either simplify, which is probably the most common way people say it, simplify. Or you can say substitution. Substitution, okay? This might sound weird. Okay, why do you think substitution works that way? Right, I'm pretty sure simplify makes sense to you guys. But the reason why substitution will work too, remember the word substitution is you're just switching out, right? You're switching one thing out for another thing. So the first thing you're switching out is this, 6x plus 2x, you're switching that out for 8x. Right, that's why it's called substitution. Okay, you're just switching those two. Okay, step 4. Step 4, my next step, I need to add that 2 to the other side. So my new equation is 8x equals 32. And this is what we call our addition property of equality. But instead of writing that whole thing out, you can literally just say addition prop, add prop for short, okay? Ken Ibrahim, oh, I said your name. I think you're okay with that, right? And then the next step is divide, good. Okay, it's not too bad, right? It's not too bad. You would divide by 8. So now I would have x equals 32 over 8, okay? Don't jump the gun, don't jump the gun yet, right? Some of you guys are probably saying x equals 4. You can't do that yet, okay? Don't jump the gun. So this would be called division property of equality. Technically, that's like the official name, but we can just call it division property. Okay. I'm getting a feel for how this works here, guys. And lastly, step 6. Ah, step 7. Oh, I think I messed up somewhere. Oh, no, it's okay. It's okay. Step 6 is now x equals 4. This here would just be simplify, or we can call it substitution. Okay. So this here is your first example of a 2-column proof. Okay, we call this a 2-column proof. Specifically an algebraic proof, right? This is something you've done before, algebra, but you're really explaining every single step, right? And I know that's probably like very annoying, but I mean, this is what your brain does. Literally, your brain does this, right? But it does it at a very high level right now because you're used to this, right? So your brain does this like in a couple of steps, but in reality, this is what you're doing, and you know you're doing that, right? You just now have to explain it. Okay, pretty cool with that? Pretty cool, pretty cool. Oh, that's the key. Oh, any questions? I need to get better at that. Questions? Questions, comments, concerns? Or just give me a thumbs up if you're good. Virtual thumbs up or physical thumbs up. Okay, thank you. Okay. Yes, let's go through this real quick. Okay, so algebraic proofs. We really just did an example already. Left side are your properties. Okay, again, you can shorthand them as I was doing in the proof there. But just to give you guys the algebraic expression. So for addition property, if A equals B, then A plus C equals B plus C. Okay, so you can see here, I just added the plus C for addition property, right? Whatever you do to one side, you do to other. You can probably get the gist of where we're going with this now. If A equals B, then A minus C is equal to B minus C. Whoa, shoot. A minus C is equal to B minus C. Okay, same thing if A equals B, then for multiplication, A times C equals B times C. Okay, your 3 basic properties there. Oh, 4 basic properties. And now some new ones, okay? Reflexive property, kind of think of it as like reflection. Okay, kind of think of it like reflection. So reflexive property is simply when A equals A or B equals B. Okay. This, we won't use this, won't use until chapter 4, I think, chapter 4. Okay, you probably think, oh, what's the point of that step? In chapter 4, you'll see why we would use it, okay? The metric property is when if you have A equals B, then B equals A, right? Oh my gosh, and B equals A. I'm sure you guys already know this in math, right? Like you got X equals 4. Oh, I have part right over here. When X equals 4, you can still write 4 equals X. Right, like they mean the same thing. But technically speaking, if you want to switch it, you use the step called symmetric property. Transitive property is basically double substitution. Make a note of that. Double substitution. So if A equals B and B equals C, then A equals C. And then substitution distribution, and then we had that down already. So these are your properties, okay? And that's essentially all the new information. All right, mainly these 3. We did this example together already. Okay, so you guys should have that. That's basically your key. Okay, let's get some practice here, okay? Right now, I'll do 1. So we'll do 1 together, and then you do 2 on your own, okay? So, number 1, you're given this equation. Okay, you're given that. And you're trying to prove that in the end, x equals 3. Right, you're just solving for it. So A should be given, right? That's the first thing that you should always write. It's like the free point on your test, okay? You write given. This here should be a 2. I think it got messed up here. All right, that's why, yeah, please fix that. I don't know what happened there. Should be a 2. Okay, that's multiplication property. What happens next here? C would be simplify, right? They simply just simplify, or you can say substitution. Next step, you can see that they subtracted the 6 here. So it's your subtraction property. Subtraction property. Feel free to shorthand, right? Math is about shortcuts. Going from step D to step E here. This here is 12, and that's substitution. Or again, you can use simplify. The book interchange that. Substitution or simplify works. This here will be 12 divided by 4. And then x equals 3. Yay. All right. Questions, comments, or concerns for example 1? All right, if not, please spend a quick minute to do number 2, okay? All right, you can check your answers right here real quick. Okay, again, remember substitution or simplified. For algebraic, you can use that interchangeably. Okay, hopefully we're good with that. Again, if you need to check back at the notes, okay, the keys are always on Canvas, okay, for you to look back at it. Flipping over to the back side, I'm just going to briefly talk about this, and you'll finish the exercises for homework. This right here, guys, we're just slightly transitioning to a geometric proof, okay? All it's saying is your original properties of reflexive, symmetric, and transitive property. It's just letting you know that not only it applies to algebra, it also applies to geometry, right? Like you use it for segments, right? Segment AB equals AB. Symmetric, right? You can switch them to. And transitive, right? AB equals CD, CD equals EF, then AB equals EF. Right? Just letting you know it works for segments and angles. Okay, that's all that is right there. Okay. I was hoping we could do a couple of these, but it seems like time is running out. I want you guys to transition to your next class easily. So your homework, finish the notes here on this side, okay, which is pretty quick. Try to finish this, the key, right? Basically finish your notes, right? Finish notes. And there are some problems